Hi, today's my topic is about mitigating DDoS attacks with advanced machine learning techniques. And coming to the introduction part, nowadays the cybersecurity has become the top priority in the digital age and the organizations as well as individuals. And the second one is IDS. We are mainly focusing on the IDS. Traditional IDS, intrusion detection system, are proven to less effective against the emerging the complex cyber threats like malware and the DDoS attacks. In this case, we are taking the machine learning algorithms too, which is the AdaBoost and support vector classifier. And these two algorithms are from the machine learning, and the MLPA machine learning multi-layer precipitation is an advanced machine learning techniques. It used to provide the ideas accuracy and efficiency, contributing the better cyber security strategies. Coming to the background research, the background research is a critical need for the research combines eye detection accuracy and learning based ideas are the most studies focusing on only one thing. Many models lack the generalizability with as we can see in the studies mainly specify on areas like IoT, limiting their broader application. Additionally, there is a gap in comparing the different machine learning algorithms, make it unclear and with methods balance accuracy and efficiency best. Coming to the proposed system, in the proposed system, uh, we are using the advanced machine learning techniques to enhance the cyber security and improve the attack detection. And the system integrates the MLP, including the DABU support vector classifier, to classify the cyber attacks effectively by evaluating the system accuracy, precision, and F1 score. And also, it is provide the robust and solution for the real time. Coming to the system design, in the system design, as we can see, the first one is the data set. In the data set, we are taking the data, and the first step is the data pre-processing. In the data pre-processing, the data has been pre-processed, and move on to the second one is the feature selection. In the feature selection, we are selecting the features, and second and the next step is the data transformation. The data has been transformed, and the next step is data boost. And these are three techniques. And later on it move to the input, which are giving the inputs and algorithms, and these are the class labels. Coming to the implementation steps, first thing we are in the implementation stage, data transformation analysis, feature selection. As we are moving to the coding part, as we can see, we are using the anaconda prompt. The first step is the conda activate my project, and later we copy the path, and this is the file. As we can see, this is the file, and later we are downloading the Jupyter notebook. Yeah, as we can see, it is been directed to the file. In this HTML, we can see the first one is segregation, pre-processing, and model training. Segregation, pre-processing, and the model training. As we are going to the segregation, the first step is import pandas. Mainly, when we are downloading the data is been in the Parquet format. We are converting the Parquet format into the CSV format and segregation file. Coming to the import pandas is to handle the CSV files and data frames. And coming to the numpy is an array which is used for the files. uh, uh, Coming to the libraries files, import library path is to handle the libraries with the versions. Coming to the matlob is to show the handle the plot graphs. And the TQDM, as we can see, the TQDM is to progress bar, where we are loading our data, shows the progress bar. Coming to the data directory, where it is in downloaded data, where we have the folder name. Data directory path it is a variable. And In the next step, we are loading and merging the data. I am loading all the files, and as we can see here, we can train the data. It This is in progress bar, as we can see 17 and 17 out of records. And this is the training data. As we can see, the length of the training data is 7 files, and the length of the test is 10 files. And coming to the next step, here I'm concatenating all the complete training data and how many records are there we are seeing. And here we can see the exactly 1,25,000 and 170 records are there, and 78 class labels are there. Coming to the next one, it has been showing the testing data only 5 records. We have taken only 5 records out of the data. And here I'm concatenating all the training data set files, and we are merging into the form of the parquet. As we can see the training data, this is a head file, test of the head file, and this is the loading in the parquet format. And here we are analyzing the data in this. As we can see in this one, this is the parquet format. And on the next tab, it is in shape of the file of the header shape. And now the data is having and now we are analyzing the data and analyzing a visual column. Here I am checking the how many labels are there. Data set is completely in balance. Here we can see the data set is completely in balance. Each label as having us so much difference from the class. Here I'm taking out of this, I'm taking only five labels which is having the more records. These five ones: the DDoS, NTP, TFT, B9, SYN, and UDP. And minimum is 18,000 records. And now the data set is 90,000 records and 78 colors. Here we are visualizing the label feature using the bar chart. As we can see, we are filterizing and targeting the sample class labels. As we can see, this is the sample of the data set, and here we can see the final sample data set. This is a final visualization data integrity checks. As we can see, out of these files, we are taking 18,000 records. And coming to the final sample data, in this step, we are removing all the float or the null values. We are removing all the float and null values. As we can see, zero infinity value. We are removing the infinity values to check the infinite values, or no zero infinite values. And as we can see, this is the segregation. This is the segregation process. Coming to the pre-processing, in the pre-processing, warnings, import warnings. Warnings is an error. It will show the which is the error or the row or the column. You know the pad maximum rows, pad maximum columns, and cbond. As we are importing the cbond is the plot the graph and the classification report. And pickle file. Pickle file also is one of these scalars. As we can see, the minimum scalar is to convert the range from the 0 to 1. sklearn is to divide the training and the test data into x and y. Coming to the second step, as we can see that the data set we are taking the final data set, which is in the CSV format. And also we are taking the 90,000 records and 78 classes. Out of this, we are testing the header files, only the header files. As we can see, the header files. And we are taking the class labels, and we are visualizing the same chart, visualizing the chart. As we can see, the no null or the no infinite values. Yeah, as we can see. And the next one is the printing the 5 class labels, info printing. As we can see, the info printing. And here I am printing which are important columns, correlation head map. As we can see, these are the, and this is the correlation EPAM, which is the relation between the columns, showing the printing the features of the important. Yeah, as we can see here. Yep. And also the next step is the printing the shape and the head, printing the shape and the head of the records. And we are giving the y input labels, x header labels. Here we are giving the x header shape, x header, y header shape. And next one is the data normalization. Coming to the data normalization, we are converting, we are converting and saving the file into pkl skl scalar. And later on we are splitting the data. We are data splitting the data into 72,000 in training, and 18,000 in the testing, 77 columns in training and one column in the testing. And here we are having the sample of the data set, as we can see. And at last we are saving the splitting data. We are saving and the splitting data in x train into csv, and x test, and the y train and the y test. And next step is the MLP model training. And in this, we are using the SVC AdaBoost machine learning. MLP MLP is in deep learning. Compared to the MLP, deep learning give the best performance. Coming to the sklearn, we are going to use the SVC AdaBoost sklearn. Yeah. And in this we can printing the dataset shape records and header records, as we can see. The support vector classifier, we use, this is the same as the support vector classifier. Here we are importing the scalar. In this we are testing the x test values only. As we can see, x test values we are printing. SVC model knows the fitting the training. We are fitting the training and predicts the data set into x test values. As we can see, this is the x test values and this is the y test values. We are taking the class labels b9, DDoS, NTP. These are the 5 class labels which are taken. As we can see, this is the model accuracy score, and this is the precision, recall, F1 score, and a support. As this is in a confusion matrix. These are the truly positive class labels. B9 gives the 3345, and DDoS is 2009, and 2009. As we can see, the AdaBoost classifier model in the in the SVC model, the accuracy is 89.59%. As we can see, the ER model is 89.5. And the next step is the AdaBoost classifier. In the AdaBoost classifier is giving the same X test values and Y test values. As we can see, these are the values. And here we can see the precision. Here the AdaBoost classifier is giving the less compared to the SVC 87.05, which is not as accuracy as SVC model. As we can see, the true class labels, Y class labels. And this is a confusion matrix of the class labels. And we are slaving then training the model with an model AdaBoost classifier. uh, next algorithm is MLP, which is an advanced machine learning model. We are importing the TensorFlow, which is in a subsequent, which we are dense batch normalization. The batch normalization is a command which is to normalize the data. And in this we are first we are training the data, and later on we are performing the models kernel. See, we can first we are training the model, and as we can see the dropouts, these are the dropouts. And later we are going to the plot graphs of the accuracy. The MLP model shows the accuracy plot graphs. As we can see, the accuracy and the accuracy of the loss and the gain. This is the gain graph, and this is the loss graph. And MLP model prediction, as we can see, same as testing labels and class labels. And this is the precision. The MLP model is giving the as much as good accuracy is 99.52%, which is more above than the MLP, which is more above than the SVC and the AdaBoost, which is an exact 99% is giving the accuracy. This is a confusion matrix B93627 3553. And And this is the coding part. This is the coding part. Coming to this three model training techniques. This is the SVC evaluation. How the class. This is the classification report. This is the confusion matrix for the SVC. Same as the ADA-Boost. Same as MLP. Coming to all these three algorithms, the MLP is giving the 99.47 accuracy. It is an ability to learn complex patterns in data made accurate and reliable model. And the SVC is giving the 89.42, and the ADA-Boost giving the only 78.45, which is made difficult in handling certain attacks types, shown as the poor recall and some attack categories. Coming to the conclusion, as we can see, the MLP is giving the best for accuracy for both benign and attack traffic, making it suitable for real-time DDoS detection. ADA-Boost precision limitations suggest areas for improvement. Overall, the study highlights the machine learning potential for real-time cybersecurity applications. Real-time cybersecurity applications. By the end of this project, we are able to know that MLP and MLP and SVC are giving the best accuracy, and ADA-Boost need to improve the model robustness, exploring the recruiting new neural networks, and as well as would even able to better detection in resource environments. Thank you. This is my project. Thank you so much.